Yeah, hello everyone. Welcome to Akshara IIT Foundation. This is Srinivas, your maths faculty. Let us move on to the today's class. Yeah, today in the class Geometry Synop 6, we need to discuss about that exercise problems. Okay, let us go to the exercise problems. Yeah. So if the bisector of a vertical angle of a triangle is perpendicular to the base of the triangle, perpendicular to the base of the triangle, then the triangle is. Let us see here. Yeah, the bisector of vertical angle of triangle. For example, we are taking a triangle like this, triangle ABC, vertical angle of a triangle's bisector. That means if I am taking the triangle A, its angular bisector. Angular bisector means it divides the angle into two equal parts. That means angle A, for example, angle A is 100 degrees. This line divides the angle A into 50 degrees and 50 degrees, two equal parts. Okay, na? So that is the bisector of vertical angle is perpendicular to the base. It is perpendicular to the base. To the base it is perpendicular, it seems. Then the triangle is, which type of triangle is possible for this? So actually, while we are discussing about the types of a triangle, we have so many types of triangles like based on sides, skeleton triangle, isosceles triangle and equilateral triangle. And the property, while you are observing the properties of an equilateral triangle, the median of a triangle, altitude of a triangle, angular bisectors of a triangle, all are coincide each other to equilateral triangle. Okay, ma? Median, altitude, angular bisectors are coincide for a equilateral triangle. That is the property of equilateral triangle. So as you are observing here, the angular bisector, see, angular bisector is perpendicular to the base, then it can be equilateral triangle. It can be equilateral triangle. Okay, so let us move on to the question number 7. Yeah, seventh question, in the given figure AB equals to AC. Let me draw the diagram first. So it is triangle ABC. Yeah, triangle ABC. AB equals to AC, it seems. AB equals to AC. And also E and F are the points. For example, E and F. 2 points are being here to connect each other like this. Okay. And the intercepting point is taken as O. Right. So in the given figure, AB equals to AC. BE and CF are respectively the bisectors of angle B and angle C. BE and BC are angular bisectors. BE and BC are angular bisectors. That means BE divides the angle B into two equal parts. CF divides the angle C into two equal parts. Okay. Now we need to prove that which of the following are congruent. Just observe the options EBC and CFB. EBC, CFB. Let us take the same triangles. EBC, this triangle. Okay, na? So in triangle EBC and CFB. Okay, right. Let us say this. In the triangle EBC, this one, this triangle, while you are observing this triangle, BC is a common side. Okay, na? But these two triangles, see, I am drawing like this separately. ECB, here E will be there, C will be there, and B. ECB and FBC. So while you are observing these two triangles, both are having a common side. Both are having a common side. So we got the first measurement. So BC equals to BC is a common side. Okay? Yeah. So to prove the congruence rule between them, we need two more measurements. We need two more measurements. Let us try to identify the measurements. We know already AB length to AC length equal. From this we can say that ABC is an isosceles triangle. In isosceles triangle, base angles are equal. Base angles means here entire angle B. Entire angle B means in EFB. Sorry, FBC is equals to angle C. That means we can take this one FBC equals to angle FBC equals to angle ECB. Okay, na? Angle ECB. So first side we have got the common side and two equal angles we found based on isosceles triangle. That means triangle ABC is isosceles. ABC is isosceles. Okay, successfully we found two measurements. Let us try to find the third measurement. Third measurement. Yeah, that too here you should remember that we know already angle B and angle C both are equal, and also angle BE is bisector of angle B. That means it divided into two parts. For example, if you take angle B 60 degrees, angle B 60 degrees, angle C also 60 degrees based on isosceles triangle. If you take half of the angles 30-30, here also 30-30 angles are equal. Okay, and while you are observing here from this angle, see this one FCB, angle FCB is equals to angle EBC, angle EBC. Okay, na? So based on the angular bisectors, it is already equal. So there half of the angles also equal. If base angles are equal, there half of the angles are also equal, right? Now two angles one side. Two angles one side means there are two properties, AAS property and ASA property also. So two angles and included side. Yes, two angles and included side. So we can take that ASA congruent rule. ASA congruent rule, triangle EBC. EBC is congruent to triangle FCB. FCB. This is our required answer. Go through the option, which is the given option is given like this EBC and FCB. You can go through that option. Okay, na? So let us move on to the next problem. Problem number 8. Okay. So while you are observing, the eighth question is, if the altitudes from the two vertices of a triangle to the opposite sides are equal. Altitudes from two vertices of a triangle to its opposite sides are equal. It means altitudes are equal. Then the triangle is, what is the triangle? While you are observing here, to discussing about that isosceles triangle, two sides are equal. Two sides are equal. Same way, two angles also equal. And while you're drawing the altitudes from vertex angle, altitude length is somewhat different from B and C, base angles. Because here base angles are equal, obviously their opposite sides also equal. It means B opposite side, C opposite side equal. So while you're drawing the perpendicular like this, in isosceles triangle, two altitudes are equal, or two heights are equal. Okay, na? In isosceles triangle, two altitudes are equal. Okay, if you observe that equilateral triangle, three altitudes also equal. The length of three altitudes are equal in equilateral triangle. The length of two altitudes are equal in isosceles triangle. But the question is asking that two altitudes are equal here. About only two altitudes. Okay, na? Now let us move on to the question number 9. That is, in the given figure, angle A is equals to angle C. Let me draw the diagram. So it is somewhat looking like zigzag. Yeah. So here A, B, C, sorry, A, B, C, here B will be there. Here A, here C, and in between D will be the point A to D is joined, and also E is a point we are taking, E to C is joined. Okay, and angle A equals to angle C. Angle A equals to angle C, and this is intersecting point O. Okay, AB equals to AC. AB length to AC length to equal. Okay, na? AB length, sorry, AB length to BC length equal. AB length, BC length equal. That means if you joined AC like this with the line segment, we can take this triangle is isosceles triangle. Okay. Then which of the two triangles are congruent? The triangles are taken ABD and ABD and BCE. Two triangles are taken. ABD, BCE. Yeah. Let me draw the two triangles separately here. ABD triangle is looking like this. ABD and BCE. BCE means BCE. Okay, right. Now while you are observing these two triangles separately, I have written, and that two here we know that angle A is equal to angle C. First measurement we got. That means in triangle ABD and triangle BEC, from the two triangles we are having equal angles from the given information. Angle A equals to angle C. It is given already. First measurement we found the both triangles having equal angles. Okay, coming to the second one, angle B is a common angle between both of them. Angle B is common angle between them. Angle B is equals to angle B, nothing but common angle. So two measurements we got. What are the two measurements? There are two angles are given. So when you find two measurements as angles, we are having two congruent rules. What are the two congruent rules? ASA congruent rule, AAS congruent. That means we need to focus on the side now. What are the two sides? AB length to BC length to equal. We already given that. AB length, BC length equal here. AB length, BC length equal. AB equals to BC. Okay, na? Two angles. Is it included side? Yes. Two angles touched by the side AB. Two angles touched by the side BC. Yes. It is ASA congruent rule. Which congruent rule? ASA congruent rule. We can write these two triangles are congruent. That means triangle ABD is equals to or is congruent to ABD congruent to A to B, B to D. See CBE because angle A, angle C equal. So based on the angle I have written like this. ABD and CBE are equal. So that is our correct answer. Let us move on to the next problem. Okay. Now problem number 10. Right. The 10th problem is given that in the given figure AB equals to EF. So let me take a diagram that is AB, BE is a line segment, A to B is one perpendicular is given, and F to E one perpendicular. F to E one perpendicular, yeah. And also here C is a point, here D is a point. C to F and A to D are joined like this. The intersecting point is taken as O. Yeah. Now coming to the question, AB length equals to EF length. AB length equals to EF length, and the second one BC length equals to DE length. BC length equals to DE length. Now here to here, BC length equals to DE length. Okay, na? And AB is perpendicular to BD. AB is perpendicular to BD, making 90 degrees angle, and EF is perpendicular to CE. Then, which of the following triangles are congruent? So we can take ABD is a triangle. From this given figure, we can identify two triangles. They are nothing but triangle ABD and the second triangle FEC. Okay. Now try to identify the sides or try to identify the measurements, three measurements from each of the triangle. Okay, corresponding measurements. AB, EF equal. So the first measurement is AB equals to EF. AB length equals to EF length. It is given clearly in the question. Okay. Next measurement. Angle B is equal to angle E is equal to 90 degrees. Angle B is equals to angle E equals to 90 degrees. Two measurements I got. Coming to the third measurement, while you are observing the third measurement, focus here. Let us consider CD distance is X. CD distance is X. Now B to D, BC length, DE length, same. For example, if you take BC length is 6 centimeters, DE length also 6 centimeters. Now B to D, X plus 6. Same way C to E also X plus 6. So from this common side, by taking the common part, we can write that BD distance equals to CE distance. We can write that BD distance equals to CE distance. Okay, na? From figure. Right. So while you are observing here three measurements, two sides, one angle we can see. Two sides and one angle. Right. What are the two sides? Two sides, that angle is nothing but side, angle, side. That angle is included angle. So we can apply SAS congruence. But all are thinking that it is a right angle, no? So we can use RHS congruent. But RHS congruent, hypotenuse must be equal, but we don't know any information about the hypotenuse of both of them. So we should take only SAS congruent. By using SAS congruent, we can write triangle ABD. Triangle ABD is congruent to triangle FEC. Okay. So let us move on to the problem number 11. Yeah. The problem number 11 is in the given figure PS equals to PR. So let me draw the diagram here. So diagram is here one line segment is given, that is TQ. Yeah, TQ, and here one letter P will be there. Both are connected to P. Yeah. So PQT is a triangle and middle two letters are taken S and R. Here S, R, both also connected to P. Okay? Right. So in the given figure, PS equals to PR. PS length to PR length to equal, and angle TPS. TPS, this one. TPS is equals to QPR. QPR, this one. Okay, no? Right. Then which of the following two triangles are congruent? Let us take PST, PRQ, two triangles. PST. So left side triangle, this one. PST triangle in triangle PST, and the second triangle, this one. PQR. Okay, na? PST and PQR. Take these two triangles. Now, in the given figure, we know PS length to PR length to equal. So from this first triangle PS length equals to PR length from the given figure. And angle also equal. What is the angle? TPS. Angle TPS is equal to angle QPR. So these two clearly given in the question also. Now we need to find the third measurement. What is the third measurement? Any other clues are given? So just read the first question. Means first sentence again from the question. In the given figure, PS equal to PR. Yeah, PS equal to PR. Yeah, that's it. We did not get any other information. Okay. Now coming to, yeah, let us look at this. Now if you take the triangle PRS, PRS means middle triangle, this one. In the PRS, two sides equal, we can consider the PRS as isosceles triangle, am I right? So in PRS isosceles triangle, base angles are equal. In isosceles triangle, base angles are equal, and we know PQ is a straight line. If you take this angle is equal, their exterior angles also equal. Their exterior angles also equal because both of them having on same straight line. So from this we can write that PST is equals to PRQ. PRQ because of triangle PSR is isosceles. So in isosceles triangles base angles equal. So nearby the base angles their exterior angles also equal according to the given diagram. Okay. Now two angles one side. Two angles one side. Just observe the two angles on one side. Both that side can be the included angle or not. If it is included angle, we should use ASA congruent or else AAS congruent rule. Okay. So we can take that by ASA congruent because it is included angle. Triangle PST is congruent to triangle PRQ. This is the correct congruent rule. PST equals to PRQ. Okay now. So let us move on to the next problem. Yeah, 12th problem which is given that in the given figure AB equals to CD. So let me take the figure that is CA as a straight line is given and A to B one slant. So A to B here C and also C to D. Next D to A is connected and also C to B is connected. So from the question you will observing that the given figure is having some clues that is CD length, AB length equal. These two sides are equal. Okay. Next. Yeah, E will be there here, intersecting point E will be there, and also BC length, AE length equal. Right. So let me read the question once. So in the given figure AB equal to CD, yes, AB length equals to CD length, and AD equals to BC. AD length equals to BC length. Okay. Right. Then what we have to prove? Yeah, 1 second, children. Yeah. So we need to prove that the triangle CDA and BAC, two triangles are congruent or not. CDA and BAC or ABC. Right. So I am taking the triangles like DCA. See, I am drawing here separately. DCA like this will be. Yeah, DCA. Here one measurement. Here second measurement is given. Also second one BAC. So this is A, this is C, and it is B. BAC. Here also one measurement will be given like that. Okay, na? So while you are observing these two triangles, I am separating these two triangles I have drawn here. That means in triangle ADC or ACD and triangle ABC. While you are observing these two triangles, DC length, AB length equal. DC length equals to AB length. DC, okay, DC. Next, AD length equals to BC length. AD length equals to BC length. So, two measurements is clearly given in the question. What about the third measurement? What is the third measurement here? The third measurement is AC and here AC. AC and AC are the common side. Okay, na? Third measurement is common side. So all of them are sides only. So which property? SSS congruent rule. From this SSS congruent rule, we can write that ADC is congruent to AD. Two lines to ADC. Two marks to this one mark. Same way CBA. This is our required answer. Okay, please look into it. So we'll go to the next problem. So problem number 12, in the given figure, AB is equals to AC. D is a midpoint. Sorry, D is the point on the interior of triangle ABC such that angle DBC equals to DCB. Okay. So this is also we need to go through the diagram. So let me erase the 11th one. Yeah, problem number 13. Problem number 13, that is ABC triangle. If you take ABC triangle, D is interior point such that you are taking that AD like this. D is interior point such that B to D, D to C, where base angles are angle B, angle C are equal. Okay. Same way AB is equals to AC also. Right. So in the given figure, AB is equals to AC. AB equals to AC means which triangle? It is isosceles triangle. Any two sides are equal means we can consider it is an isosceles triangle, and isosceles triangle base angles are equal. So let us take the triangles ABD and CAD. ABD and CAD. So left side and right side triangles. These two triangles I am going to take. That means in triangle ABD and triangle CAD. Both triangles where you are observing here. AB equals to AC. First measurement. AB equals to AC. That is already given in the question. Now AD is a common side. AD equals to AD is a common side. Okay. Any other measurements here? Third measurement we need. What is the third measurement? Third measurement is BD equals to BC. BD equals to DC. How can we take the third measurement is BD equals to BC? Because BDC is isosceles triangle. Here base angles are equal in this triangle. If base angles equal, automatically their sides also equal. These two. Okay, na? Because triangle BDC is isosceles. So side triangle by SSS congruent. We can write that ADB is congruent to ADC. ADB is congruent to ADC. Okay. Right. Next question number 14th one. Yeah, question number 14. In the given figure, LM equals to LN. Let me draw the diagram here. Question number 14 is the diagram. PQR is a triangle. Yeah. PQR is a triangle, and here M is a point. From M to PR one perpendicular has drawn, name it as N, and M to L. So these two perpendicular lines. Okay. So from the given figure, LM is equals to MN. LM equals to MN. Both are equal. And QM is equal to MR. QM equals to MR. Next, ML perpendicular to PQ and MN perpendicular to QR or PR. Then what are the two triangles are equal? So I am taking the two triangles like MQL. In triangle MQL and triangle MRN. These two triangles. Now check these two triangles. We know already given measurements. ML equals to MN. It is already given in the textbook. And QM equals to RM. These two are given. Now what is the third measurement? Look at those two triangles clearly. Here 90 degrees will be. Both are 90 degrees. So angle MLQ is equals to MNR is equals to 90 degrees. So right angle opposite side is hypotenuse and one of the side. So by RHS congruence. These two triangles are equal. What are the two triangles here? So triangle MLQ is congruent to triangle MNR. Okay. Let us move on to the next question. Right. Yeah, that's it for today, children. Thank you one and all. Have a nice day. Bye bye.